Hi, I'm Walid Sassi, Mobile Technical Leader. Welcome to this model on the evaluations framework, new in Xcode 27, and Apple's answer to a problem you hit the first time you ship an AI feature. You have built something on a language model, it works, you want to test it, and you can't. That's what we are going to solve. Before we get to the framework, let's understand why we need it. 3 ideas, and each one leads to the next. There is an assumption behind every test we write. Language models break that assumption, and when it breaks, our tests break with it. Let's go through them one by one. Let's start with the assumption. It's so obvious that we never think about it. Every test you have writing calls a function with a known input, knows what should come back and asserts equality. The function is deterministic, so the assertion is meaningful. Now put a language model behind it. Ask for a 3 days itinerary in Kyoto. Run it again. You get a different itinerary. And here is the part that's hard to accept. Both answers can be completely correct. There is no single right itinerary for 3 days in Kyoto. So expect that the result equal to expected value doesn't become flaky, it becomes meaningless. So it's tempting to give up. If you can test it, don't test it. But that choice isn't free. You pay for it later in 5 ways. The first one, silent regression. You tune a prompt to fix one behavior and you break another one. No red test, no crash, no log line. Nothing tells you it happened. The second one, false confidence. In false confidence, your suite is green, but green means your networking works, your parsing works, your view models works. It says nothing about the quality of what the model produced. Third, no way to measure progress. You change the prompt. Is the feature better? You can't say. You have an opinion based on 3 manual runs. That's not a measurement. Fourth, eroding user trust. The failure your users hate are the ones you never saw. And an AI feature that is confidently wrong damages trust faster than one that simply crashes. And finally, we have compounding drift. Each regression is small on its own. None of them matter, but they accumulate, and slowly the feature stops doing what it was built to do. The framework defines every evaluation in terms of 3 components. This structure is fixed. It applies to any feature under test, regardless of the task. We'll define each component here because the demo that follows compose all 3 in the same order. First, the dataset. They are your inputs, the prompts you want to test the feature against. Real ones, the kind a user would actually type, and each input can carry an expected value. Second, the subject. This is your feature. Think under the test. Take one input from the dataset and produce the output we're going to judge. In our demo, that's a triplanar. A travel brief goes in, a structured itinerary comes out. Third, the evaluator. They are the rules that grade the output, and they are 2 kinds. Some pass or fail. Did the model respect this construct? Yes or no? Other return what we call the score. Now, let's check the evaluation framework. First, the evaluation framework comes with Xcode 27, currently in beta 6 version. On macOS 27, so this is early, I think, details that may still move until September. We use the macOS 27 using what we call the Golden Gate version. It's built for feature powered by foundation models running on device. No network, no per call cost, which makes evaluating across a large dataset generally practical. And it plugs right into Swift testing. That's matter more than it sounds. Your evaluation aren't a separate harness someone has to remember. Now, let's build one. Try planning features powered by a language model. We'll put under evaluation, then read what Xcode gives us back. In this demo, we are going to build a complete evaluation for an AI-powered features using Apple new evaluation framework. First, we start with the import of the evaluation framework. It gives us metrics, evaluator, and the aggregation API. Foundation models is what actually run on the device model behind our feature. And also we have the testing framework, which is the Swift testing framework. Next, the shape of what our feature produces. This is the contract the model has to fill. We have an itinerary with a list of daily plans, total estimated cost, and overall pace. The generable macro makes this a type the model can produce directly, and each guide gives the model a plain language description of what that field means. Notice that pace is a small enum composed of relaxed, moderate, or peaked, which pins the model down to a fixed set of value instead of free text. Here the feature itself, a plainer wraps a language model session behind one sample method, plain trip. The session is created with instructions. This is the system prompt that steers the model. Build a day-to-day itinerary and group activity by neighborhood so the travel isn't crossing the whole city twice a day. Now we get to the heart of it. We declare a type that conforms to the evaluation protocol. This protocol asks us for four things: a dataset to run against, a subject that produces the output, the evaluator that grades it, and an aggregation step that folds all those per sample grades into summary numbers. First, the dataset. Each model sample pairs a prompt, what a user should actually type, with an optional expected value we can compare against. Here we have a single sample, 3 days in Kyoto, moderate budget, temple and food, with an expected cost of around $900. One sample is plenty to wire everything up, but it's not enough to trust the number. Now we move to the subject. The subject is the bridge between the framework and our feature. For each sample, we spin up a trip planer, called a plain trip with the sample prompt, and wrap up the result in the model subject. And alongside the value, we hand back to the session transcript. That transcript is what powers the detailed per sample report in Xcode. Later, when a metric looks off, this is where you will see exactly what the model was asked and exactly what is answered. Before we can grade anything, we name what we are measuring. A metric is simply a named channel for results. We define 3. Days count to confirm that itinerary has a sensible number of days, activity per days to confirm each day is neither empty nor overloaded, and budget with tolerance. Now the evaluators. One row each. The first reads the generated itinerary and check that the number of days falls in a plausible range, 1 to 14. If it does, we return a passing result. If not, failing 1, and we attach the actual count as a rational, so the report tells us why it's failed. This is a deterministic check. Plain swift, no modal judgment required. The second evaluator enforces our per day rule. Back in the guide macro, we told the model that each day should have 2 to 4 activities. So here, we actually hold it to that. Every day in the itinerary has to satisfy the range. If a single day falls outside it, the matrix falls, and the rational list the count we saw. The third evaluator is a different kind of measurement. Budget isn't a clean yes or no. So instead of passing or failing, we score a magnitude. We compute the relative error between the estimated cost and the expected cost, how far off as a fraction, and record that number with scoring. If there is no expected value for a sample, we simply ignore the matrix there. 0 will mean a perfect match. The larger the number, the further the model drifted from the budget we had in mind. The last requirement of the protocol evaluation is aggregate metrics. The framework hands us an aggregator in-out, so we write into it. And our job is to declare for each metric how all these per sample results get folded into one summary number. 3 metrics, 3 lines. Compute mean of activity per day, compute mean of days count, and for budget within tolerance. That's it. That's the whole aggregation step. Everything defined so far produce measurement. This final piece converts those measurements into binary outcome, a test that a continuous integration pipeline can act on. The setup is 2 lines. Our evaluation is declared as a static property of the test type, itinerary tests. Is then passed to the test macro wrapped in the evaluates trait. That trait is what connects the 2 frameworks. It defines the execution order before the function body runs. The framework iterates the dataset, invokes subject on each sample, applies every evaluator, and performs the aggregation we declared in aggregation metrics. All of that compete prior to the first statement of the body. That ordering explains the first line. Evaluation context.current.result. Retrieve the results of the run that has already finished. The test function does not execute the evaluation, it reads its output. We then extract the three aggregate values. The call to the aggregate value mean of corresponds directly to compute mean of in aggregate metrics. The same metrics, the same aggregation written in one place and read back to the other. Now let's run the test. It fails when mean budget error assertion. My threshold was 30%. The model landed further off. The other two passes. Now let's open the report navigator in the Xcode sidebar. Notice a new entry here, evaluation. That's one new. We'll come back to it in a moment. First, click on test. This gives us the details, exactly which expectation failed, and the value that broke. Now the evaluation entry, a summary of the run. One row per evaluation. Here is ours, with a column for every metrics we aggregated. Both ratio at the 100%, budget average 0.61. To go deeper, I click the summary row at the bottom that opens the details for the sample. On the left, the same picture as before, days count and activity per day, both at 100, budget averaging 0.61, and the banner telling me the test attached to this evaluation failed. On the right, the sample itself, per metrics verdict up to top, days count pass, activity per days pass, budget scored at 0.61. And underneath, the part I care about, a field-by-field comparison. What the subject generated against what we expected. Look at the total estimated cost, for example. The model produced 350. We expected 900. This is our 61%.